Good day everyone, Cameron here from Hydraulic and Automation Warehouse, and welcome back to another how-to video. Now, if you've been following the how-to videos in the past, you'll notice that I have already spoken about these gear pumps. Today, I just want to expand a bit more on them, get a little bit more technical. Now, I'm sure you guys would have all experienced this somewhere or another. Customer phones in or you go to site and they say to you, I need a replacement on my gear pump. Mine got damaged or whatever the case may be. Then you start asking those questions. Not a problem, sir, we can help. What is the spigot, the shaft, the porting, yada yada. You go through the whole route and you get to that one question. What's the displacement or the CCs that you require? The customer will either say to you, the what, or I don't know. No problem, because there is actually two ways that we can figure out how to kind of determine the CCs of a gear pump. Now, obviously, that being said, before we start, measuring and putting in all that effort, look for a label first. 9 times out of 10, there will be a label or a stamp on the pump that tells you the CCs of the pump. Also, once again, 9 times out of 10, the pump, obviously, after a couple months or years of use, stamp would have maybe worn out or the label's missing. So I'm going to show you exactly how to figure that out if you don't have that extra information. Now, taking apart one of these gear pumps is quite a messy business. So follow me to the workshop. Let me show you what I'm talking about. Now, like I said, when it comes to finding out the displacement of your gear pump, there's actually two surefire ways of doing this. The first that I'm about to show you is actually the quickest and the easiest. All that we have to do is measure up the body of your gear pump. Now, when I talk about the body, what I'm talking about is just this aluminium piece. That's it. So grab your vernier, please. No rulers or anything funny. They're not as accurate. What we do is we just measure from end to end, and that will obviously give us 86.5 millimeters. From there, very easy. We consult the Salami brochure or the Salami data sheets, as all the measurements is actually readily available. From there, it's very, very easy to find out the CCs or the displacement. Now, like I previously mentioned, there's actually two ways to figure out the displacement or the CCs of a gear pump that you require. Now, I want to focus on your second option, actually using the displacement formula. That being said, sometimes the customer would have lost the aluminium section of the gear pump, or it got damaged, or whatever the case may be. So if all that you have to work with is, say, a gear or a shaft, no problem, because the answer is right here. Let me show you what I'm talking about. So the displacement formula is actually an easy one. It's an open bracket, your uppercase D squared, minus your lowercase d squared. Close that bracket. Just by the way, excuse my handwriting. We're going to divide everything by 4. Going to multiply that by pi. And then once again, multiply by your GW. Now, let me just break this part number down a bit. Your uppercase D squared stands for the outer diameter of the gear that we're about to measure. You minus that by your lowercase d squared, which is the internal diameter of the gear. You're going to divide by 4 multiplied by pi. Now both 4 and pi are constants, so they don't change at all. Multiply that number by your GW. GW is your gear width. Let me show you what I'm talking about. Let's measure this gear. Now, like I previously mentioned, what we need to do in order to work out the displacement using the second method, namely your displacement formula, we actually need to measure up the gear that's inside this gear pump. Very easily, remove the 4 bolts on the back of the gear pump, front flange off. If possible, work in a workshop like what I'm busy doing. Otherwise, it's just pure oil and mess. Now, what we do is we're going to focus on the drive shaft alone. Removing the drive shaft, and this is exactly what we're looking for. all the information that we require is on this little guy right here. Now, I was talking previously about the outer diameters and the inner diameters of your gears, and this right here, those are your gears. Now, getting the readings, once again, vernier please, no ruler. What we're going to do is, first we're going to start with the outer diameter. And from here, we get a reading of 38.2. Next, we're going to need to measure the internal diameters of the gears. So from here, just on the inside, obviously make sure that your gears are even, and we get 30.03. Now the last thing that we need to measure up is our GW, obviously the gear width. Obviously lengthwise on the gear, make sure everything is nice and properly aligned, and we get 41.02. Next up, I'm going to show you exactly where these figures fit into our displacement formula. Now, using the results that we got from measuring that gear, I've actually input these results into the displacement formula already. Save a little bit of time, that type of thing. Now, once again, the equation is actually a very simple one, and the best part is everybody has a calculator in their pockets at all times. 21st century. Now you'll notice the result that we got is 27 cc's. Mind you, I do have a little bit of an advantage because I handpicked that gear pump myself, so I know exactly what I'm dealing with. You'll notice, first of all, the gear pump was actually 26 cc's on the dot. So you'll notice the formula gave us an extra cc. It is not 100% accurate. However, we can use this formula to get the closest, most accurate result. That being said, we can also show you how much flow that gear pump will give using the result that we just got. Let me show you what I'm talking about. Now, like I previously mentioned, flow rate. 9 times out of 10, when you will get a customer come in, they'll say, I need to build a new power pack, or I need my machine to do, say, 40 liters per minute or 10 liters per minute, or whatever the case may be. We will need to actually figure out the flow rate that our gear pump will produce. Now, luckily, the formula for figuring out your flow rate is way easier when it comes to the displacement formula. It is actually your displacement that you would have figured out. I'm actually just going to use 26 because we know for a fact that the gear pump we have chosen is a solid set 26. We're going to times that by the RPM that the electric motor produces. Obviously, that information we just get from the customer. Sir, what kilowatt is your electric motor? Plain and simple. We divide everything by 1,000, and that will give us our flow rate. So, like I said, we're working with the 26 cc. And we've asked the customer, kilowatt, what is it? He informed us that it is 1,450, divide everything by 1,000, and that gives us 37.7 liters per minute. From here, we can obviously, if the customer requires a bigger pump or a smaller pump, whatever the case may be, we can work it out. Easy peasy. Now, once again, thank you so much for tuning in. If there's maybe something that I have missed, or if you've got any more questions or queries, please don't hesitate to give us here at HAW a phone call. We're always willing to help. This about sums up everything gear pump related, but like I said, don't be shy to anytime give us a call, send us a mail, WhatsApp if you really want to. Till next time, that's all for now.